In this lesson, we're going to be looking at radical equations. So first, what is a radical equation? Well, a radical equation is an equation that has a variable in the radicand. Remember, the radicand is the name for the term or expression that's inside the radical. So if we look at these equations, we can determine whether or not each one is a radical equation. So for the first one, we have 2x inside the radical. That means that we have a variable inside the radical, so it is a radical equation. On the right side, we have an x inside the radical, so this is also a radical equation. Back on the left side, we have a 6 inside the radical, and the 3x is not, so this means that it is not a radical equation. Back on the right side, we have 6x inside the radical, so we have a variable as part of the radicand, which means it is a radical equation. Back on the left, we have the sum of x and 2 inside the radical, so there is a variable inside the radical, which makes it a radical equation. And the last one we have that we're taking the square root of 12, so there is no variable inside the radical, so that one is not a radical equation. So we can, when we're given a radical equation, there are steps to solving them. But let's take a closer look at inverses, because we know that when we're solving equations, we need to use inverse operations to isolate our variable. And if you remember, whenever we had a variable that was being raised to the second power, we talked about the inverse of squaring, and we determined that it's the square root. So when we want to undo squaring, we square root because they're inverses of each other. If we're looking at only the positive root, that would give us x on the left and 6 on the right. So if square rooting is the inverse of squaring, then that would work the other way around too. That would mean that if I wanted to solve this next equation on the right side, and I wanted to get x alone, the only way to undo the square rooting would be to square. But I'd have to square on both sides. So when I do that, that would give me an x on the left side, and it would give me 25 on the right. So now let's take a closer look at this and see exactly why it is that this works. If I'm squaring the square root of x, that means I'm multiplying the square root of x by itself. And as we learned in the previous lessons in Module 2, in this area with radicals, we learned that when we multiply a radical by another radical, we can write it like this. We can write it as the radical of their product. So this can also be rewritten. And in a previous lesson, we saw that when the exponent on the inside matches the index on the outside, that we are in fact applying the inverse operation. So when we're squaring and then we're square rooting, we're just left with where we started. All right, so let's take a look at a few of these. When we're solving radical equations, we have two main parts. The first part is to isolate the radical. Then after we have the radical isolated, we're going to continue to use inverse operations, and then we'll isolate the variable. So let's look at this first one. We'll call it example A. In example A, our radical is all by itself on the left side. There's nothing else being added or subtracted or multiplied by it. So we've already got step 1 covered. It's done for us. So we go to the next part, which is to isolate the variable. So in order to isolate the variable, we've got to get rid of that radical. And the only way to undo square rooting something, like we just looked at, is to square it. So we square both sides. After we square both sides, we're left with just what was inside, which was the radicand before, now comes out. And then on the right, we have 2 squared will give us 4. Then we just solve it as we would normally by using inverse operations. So we get 2x equals 1, and then continue using inverse operations till we get to our solution, x equals 1/2. Now there is one extra step that we have to take when we're solving radical equations, and that is to plug back in and check our answers. So if x is 1/2, that means the 1/2 has to get plugged in right there. So let's see if it does indeed check out. We would have the square root of 2 times 1/2 plus 3, and we have to see if that equals 2. Well, 2 times 1/2 is 1, so 1 plus 3 is what we would have in our radicand. And then 1 plus 3 is 4, and the square root of 4 is 2. So, yep, it checks out. So this is our solution, 1/2. Let's do the next one. For part B, we have to isolate the radical first because we have a 6 that's being added to it. So to undo that adding 6, we would have to subtract 6 from both sides to start. We're left with our radical and then a -2 on the other side. Once we have our radical isolated, we can continue using inverse operations. So the inverse of square rooting would be to square. And then on the left, we would have x minus 5. On the right, -2 times -2 will give us a +4. And then this is a one-step equation, nice and easy. We get that x is equal to 9. We take that extra step of plugging back in, so the 9 is going to get plugged in right there. And we'll have the square root of 9 minus 5, and then plus 6 equals 4. Square root of 9 minus 5 is 4. Square root of 4 is 2. And we get 8 equals 4, which does not check out. And whenever this happens, that you get a we know that we solved it correctly and we plugged it back in, but it's not checking out. 8 certainly does not equal 4. Then this solution of 9 is called extraneous. So this is an extraneous solution. Now, you may be looking at this and saying, okay, but hold on. Go back to this step right here. If you had just taken the square root of 4 and just looked at the negative root and just said, okay, well, -2 could also be the square root of 4, then it would have checked out fine. And that's true. But when we're solving these radical equations, we are only looking at the positive roots. So when you take the square root in this checking step, you're only looking at the positive root. And if it doesn't check out at the end, then this is considered an extraneous solution. This is almost always going to happen when you're squaring a negative number, because this number started out as negative, and because of the squaring, it becomes positive. So that is usually when you're going to end up with an extraneous solution, but we have to check every time. All right, let's look at part C. So in part C, our radical is once again isolated, which is good. There's nothing being added or subtracted or multiplied or divided. It's all by itself on the left side. But this time we have radicals on both sides. But we're just going to continue using our same method of applying inverse operations to isolate our variable. So on the left, we'll have 3x minus 8, and on the right, we'll have 13. And we would just solve this using inverse operations as you would solve any other equation, two-step equation, and we get that x is 7. And then, of course, got to take that extra step of plugging the 7 back in right here. So we will have the square root of 3 times 7 minus 8, and we have to see if that equals the square root of 13. Well, 3 times 7 is 21, and 21 minus 8 is 13. So it does check out. So our solution is indeed 7. All right, we've got one more. We'll call this part D. And this time our radical is being multiplied by 2. So we have to isolate the radical. We have to do the inverse of multiplying by 2, which would be to divide by 2. We have to do that on both sides. When we do that, we'll be left with our radical, and we have done the job of isolating it. On the right side, we'll have 9. Now that our radical has been isolated, we can continue using inverse operations. It's square rooted, so we square it. That would be the inverse. And then we're left with 4x minus 7 equals on the left side, and then on the right side, 81. We continue solving, so we would add 7 to both sides. 4x equals 88. Continue solving, dividing both sides by 4, and we get x is 22. We have to take that extra step of plugging it back in right here. So we'll have 2 times, I'll make it a little bigger, 4 times 22 minus 7, and we have to see if that does equal 18. So 2 times, 4 times 22 is 88. And then we have 2 times square root of 81, which is 2 times 9. So we do get 18 equals 18. It checks out. So out of the 3 radical equations that we solved, out of the 4 radical equations that we solved, 3 of them had solutions. For part B, you would either say that it has no solution or it has one extraneous solution.